Okay, so looking at the review here, and again, this review it's kind of taking two things and put them together. It's the reasoning stuff that we did, and it's going to be with these angle pairs. So this first one is, like I said, the very first thing we did way back like 3 weeks ago or something, and it started with the inductive reasoning where we were looking at patterns. So, all right, if you'll notice on this pattern here, you can see a dot here, there's a dot there, there's a dot here, there's a dot here. Why is it that we can't see a dot on the first one? Because right here, there is a dot there. It's just that whole square is blacked out, so you can't tell that there's a dot there, but that's where it is. Okay? So notice what's happening here. It started here, went to there, went to there, to there, to there. So where's the dot going to be on the next one?
The next square.
It's going to be right here, right? So I know it's not going to be which one?
A or E.
A or D. Just.
Oh.
Oh wait, sorry, no.
E.
A or E, yeah, my bad. So those two are out just based off of where the dot's at. Now let's think about the blacked out square. So if you'll notice what happens, it goes 1, 2, and then it goes to the third one going clockwise. Right? It goes 1, 2, 3. It goes 1, 2, 3. Then it goes 1, 2, 3 to get to there. So this one's going to go 1, 2, 3, and it's going to put it right here inside of this square for the next one. Okay, so which one can I throw out based off of that? D is out, okay? Because the black square has to be in this one right here. So it's going to be one of these two. All right, and the last thing to consider is...
Like the gray one, like
The-
goes on one.
It
and the next
skips.
one. It skips one. Yeah, it skips it.
Okay, you could think of it two ways. You could think of it like that, or what's happening, it really is, I think that the blacked out one's just covering it up.
Yeah,
So it's
going
here,
this way. It's going.
moves here, the gray one's just there, but you can't tell it's there. Then it moves to here, then it moves to here, and it's there, you just can't tell. Then it moves to here, then it's going to move to here, and it's there, but you just can't see it. So which one is it? It's C.
That's a way harder way to look at
I know.
I mean, however, whatever gets you to the right place. And again, this is inductive reasoning, so, you know, that's the thing about inductive is it could be looked at more than one way and may lead to different conclusions. Okay, so number 2, I'm not going to go through the logic on all these. Which one did you get for number 2? It's D. If you think about the way the door's moving and the way the person's moving, it's got to be that one. And then on number 3, which one's going to fit in this slot right here? It is C. Okay, what number is in the sequence? Next in the sequence. Okay, so that plus that gives you that. 3 plus 3 is 6. 3 plus 6 is 9. 6 plus 9 is 15. And so anyways, 15 plus 24 would be 39. Okay, what would be next in this sequence? Triangle, quadrilateral, pentagon, hexagon, heptagon, octagon. Okay, what is reasoning based on observation and patterns? Inductive reasoning, and based off of facts and definitions is deductive reasoning. Okay, what is a conditional statement? Okay, it's if something, then something else. Okay, what is the if part called? It is the hypothesis, and the then is the conclusion. Okay, so on this one, it wants you to rewrite that statement as the converse, inverse, and contrapositive. And I will guarantee you will see that on your test tomorrow. You have to know the difference between these three. Okay, so first of all, with converse, what do we do with the converse? I mean, just in general, what do you do? Switch the hypothesis and conclusion.
If it is a right angle, it is.
Okay, so I'm not gonna write the whole sentence. I'm just gonna get to the main idea. So it's
If right.
right angle, then 90 degrees.
Inverse is like not. Give the statement false.
Okay, so on the inverse, What do you do on the inverse? Not. You negate. Put not. So what's it going to say?
It's not a 90 degree.
It's not a right angle.
Okay, if it's not 90, then it's not a right angle. All right, and then in contrapositive, what do we do?
Switch it, and it's also not.
You switch it and not, so it's both of those, right?
The angle is not right, it's not 90 degrees.
Okay, good. So if it's not a right angle, then it's not 90 degrees. All right. An example that proves the statement false is called a what? Good, a counterexample. Okay, on this algebraic proof here, how do I know that 3 times 3x plus 4 equals 12x minus 24? Because it's given. Okay, what property is used going from the first step to the next one?
Distributive.
The distributive property. Okay, going from the second step to the third step, what happened?
Subtraction.
Yeah, the 9x got moved, so it was subtraction there. Okay, what's going to be the step in between here where it's blank? Yeah, you add 24, so what's it going to equal? What's it going to be? 36 equals 3x, so addition's what happened there. Okay, going from the fourth to the fifth step, what happened? Division. Okay, and notice what we're trying to prove is that x equals 12. So, good, is the symmetric property. What flips those two? Okay, number 17 is basically the same idea. I'm going to skip over that one. Okay, number 18. So first of all, what do you notice on L and M here? These little arrowheads. So what does that tell us about those? They're parallel, okay? So that's true. All right, angle 1, it says, is 110 degrees. So how big is angle 2? 70. How do I know that? What's up with 1 and 2? They're linear pair. What do I know about a linear pair?
Equals 180.
They're always supplementary. So angle 2 is 70 degrees. Okay? So angle 5. How big is angle 5?
It's
110.
110.
Okay, how do I know it's 110?
That's
Corresponding, that's congruent.
Okay, it's corresponding to angle 1, and it's congruent when the lines are parallel, like they are in this case. Yep, I knew what you meant there. Okay, so how big is angle 7?
70. Because it's vertical.
They're congruent.
Oh, wait.
It's alternate.
Yeah.
Alternate.
I mean, there's several ways to look at it. 2 and 7 are alternate exterior, so that's 70. Or 1 and 7 are same side exterior, so they're supplementary. Okay, then how big is angle 4? Is 110 because it's vertical to angle 1. All right, what is the transversal for angle 1 and angle 7?
Same side exterior.
No, what's the transversal?
Oh.
Line in.
Is line in.
Oh.
You're good. Okay, what's the transversal for 9 and 13? Is line
Line
P. Okay, is line L parallel to line M?
Yes.
Yes, because of that right there. Is line P parallel to line N? No, at least we don't know that it is. There's nothing to indicate that, and they definitely don't look like it. Okay. What are 1 and 5? Corresponding. Okay, what are 3 and 5?
Same side interior.
Same side interior. What are 4 and 5? Alternate interior. What's 7 and 2?
Alternate exterior.
Alternate exterior. What is 4 and 6?
Same side interior.
Same side interior. What's 8 and 2?
Alternate exterior. I mean, same side exterior.
There you go. Same side exterior. 13 and 9.
4.
Corresponding. 12 and 14. Same side interior. 11 and 15.
Corresponding.
Corresponding. 11 and 14.
Alternate interior.
Alternate interior. 4 and 11. Same side interior. 3 and 11.
Or
Corresponding 4 and 9. Okay, our alternate interior 2 and 9. Our same side interior. Okay, next, first of all, it tells me that these two lines are parallel, so I know that. All right, here's a 70-degree angle. Here's the one with X in it. So what type of angles are those two angles?
Corresponding.
They're corresponding. And if the lines are parallel, and they are, what do I know about those two angles? They're congruent. So I'm just going to set 70 equal to 4x minus 2 and just solve for x. Okay, so we get 72 equals 4x divided by 4. And so what does x equal? Equals 18. Yep. All right. Now the one with y in it right here compared to the 70, what are those? They're vertical. What do I know about vertical?
Always congruent.
They're always congruent. So 2y equals 70 divided by 2, and y equals 35. Yep. Okay, I didn't put this on here, but let's say something about it real quick. All right, so the alternate interior, alternate exterior, and corresponding, okay, those three if the lines are parallel. And then vertical angles. What's up with that group? What's true of all those? They're congruent. That's true. Same side interior, same side exterior. Okay, these two if the lines are parallel. And then linear pair. What's up with those?
supplementary.
They are supplementary. Okay, these down here are basically the same thing as that, so we're good there. All right, so let's look at the back. Okay, so this angle and this angle, those are corresponding. If the lines are, well, we'll talk about that in a second. And then what are these right here? Same side exterior. Okay, if the lines are parallel, and they are, what do I know about the corresponding angles? They're congruent. And if the lines are parallel, and they are, what do I know about the same side exterior? They're supplementary. So let's set up our equations here to find the value of x and y. So with those that are corresponding, how would I set up the equation for that? Okay, good. So again, since those are corresponding angles of parallel lines, they're congruent to each other. So we set it up like that. Now these two on the right-hand side, those same side exterior, what's up with those? They're supplementary, so how am I going to write that? Yeah, you could say plus negative 13x minus 3y plus 45 equals 180. Okay, now if you just think about the equation I have in red right there, the problem with that is if I solve for x, I'm going to have it in terms of y. Y is going to be on the other side, and I'm not just going to have a pure number, just a constant. Okay, so that equation by itself is not going to lock in what x and y are. And the same thing is going to happen on the blue equation that I have there. If I solve for x, there's going to be a y on the other side, and I'm not just going to have x equal to a constant. So those two equations by themselves is not going to lock it in, but those two happening within the same system as these are will lock in a value of x and y that makes them equal in both instances. So what am I going to do here to find out what the value of x and y is? Okay, there's a lot of ways, okay? One way we did it is to solve for x on one of them, then substitute that in. It's going to be a mess if we try to do it here. The easiest way would be just to graph those and see where they cross each other. So let's try that. All right, so let's put in both of those equations, and remember, we could solve for y, but also on this calculator, you can just backspace on the equal and go to relation. And let's just type those in like they are. So we have negative 17x minus 6y equals negative 13x minus 7y plus 6. Okay, that's the first one. Then push tab and we'll put in the second equation. Negative 18x minus 4y plus negative 13x minus 3y plus 45 equals 180.
Ooh, I did it wrong.
Okay, so what am I looking for here to find this, the value of x and y in this system? I'm looking for the intersection, so where they cross. So it's down here, oops, down here somewhere. So I could look at that and probably figure that out, but what's another way I could find out for sure what it is?
Menu and intersection.
Okay, go menu,
Analyze graph. for the intersection.
6, 4. So I'm searching for the intersection. So I'm going to go to a lower bound, sweep it across, push enter, and okay, I don't know if you know this, but if you get the little hand over it, it does like this. If you'll push and hold down for like 2 or 3 seconds, it'll grab it, and then you can move it up. Do it like that.
Is that crazy?
Okay, so what's my x value there?
Three.
Negative 3, and my y value? Negative 6. All right, so x equals negative 3, y equals negative 6. Okay, and then you can plug that in and find those, the measurement of those angles. I'm not going to spend the time on that right now. Okay, so now let's look at this last one here. All right. So, what type of angle pair are those two right there? Okay, they're corresponding of parallel lines, so they are congruent. So what are we going to do here? Set them equal to each other. So I'm going to have 6x squared minus 12x plus 10 equal to 4x squared plus 4x minus 20. And we could get this, set this equation equal to 0, just move everything to one side. You could do that, or we can just type it in like this, just type this into relation. So let's do that. Okay, so 6x squared minus 12x plus 10 equal 4x squared plus 4x minus 20. So what are my solutions? It crosses at 3 and it crosses at 5. So that's where we're where those two are gonna be equal. So the values of x is x equals 3 and x equals 5. And then you can plug those in and find out which one is the correct one, but we're gonna stop there.